Hello and welcome to, once again, a macro video. But I think it's quite an interesting one this time. I finally finished an 800 line library that I've been working on for, I think, the past week or something like that. At least since my last video, at least. So, yeah. Now, what it does is actually quite simple, and it might seem trivial, but I can, for example, just do this. This works from every position. I'm not touching my keyboard, all the macro. Now, seems trivial, doesn't it? It is not. As I said, this macro is 800 lines long. So yeah. Now, if you think about it, what do I have to do to get to this block? First of all, I have to know how to get to this block. So I have to get my coordinates and then subtract the coordinates of the block from them to actually understand by how many blocks I have to walk. Easy so far, right? No. I have to actually read out the coordinates from the F3 screen to get them, because this is a macro and it's not a mod. So yeah, now after I've done that, I have to find the angle I have to walk at to actually get to the block and the time. So therefore, for the time I just do some calculations with the distance between the 2 points. But for the angle, I actually need to calculate the angle, which wasn't that easy either, because I'm not good at trigonometry. But once I calculate that, I need to actually turn to that angle, and that from any other angle. So I need to get the angle from here, and not even that is so easy, because if I look north, the angle will be offset a little from when I look east. So basically, once I've gotten that angle, I have to add the other angle to it and then turn to that angle. Turn by that set angle, and once I've turned to that angle, I have to sprint a specific distance. Once I've sprinted the distance, I have to end the program. So this is 800 lines of code in a nutshell for you. Now, I've also added a little other feature, which is just simply that I quickly have to, that I can actually walk with a higher precision when I want to sneak, and I can do that by just cranking down the speed. So I just turn down the speed, and if I now press my keys, I will actually not turn. But this is something that Wout helped me with, so thanks to him for this. Oh, and also thanks to the AHK community. Without it, I wouldn't have been able to actually make this so fast, and yeah. And what it does is to just walk the perfect distance into left and right and forwards and backwards to actually get to this block. So it takes as little time as possible, and it is very, very, very precise. So if I can do, for example, this, I will be aligned perfectly on the middle. So yeah, this is the library for you. Now, I will probably continue on this video by actually showing how this works, and then also showing how you can use this. I made some quite convenient things, I would call them. So you basically just have to download one file, although this contains in total 4 or 5 files. So yeah. Next. Yeah. Good job, me. Alright, so now to the explanation section. I'm gonna try to rush this a little because otherwise this will be half an hour. So, yeah. These first lines here are actually just for some performance stuff, and this line here sets the working gear so I can include this library here correctly. GIP is a library that is very commonly used, and what I use it for is to get the color of a pixel much faster. To be precise, or almost instant basically, because I get it from an in-memory bitmap that you can create using GDIP, and then I get the color from that. Now, after I've included it, I just set it up, and here I then read out of my options.txt, which is a file that you can is also created automatically, but I go through that later on when I show how to set this up. So here the first line contains the number of the monitor that you actually play Minecraft on. This contains your GUI scale. I always told people that they'd have to use the normal GUI scale. This is not the case for this specific background. And the third line then actually just contains your monitor's resolution, because that's important if your GUI scale is auto, because then it will just resize depending on your actual screen size. Now, to continue on, I then just take this data and convert it into a scale that I can use to, down here for example, multiply a value that is an offset by that scale. Then I have down here, sorry, hiccups, an on exit. On exit means when exiting this will be executed. And the when exiting is just the function that it executes, which is all the way down here at the bottom. Here I just delete the last image I got with GDIP. I'm gonna go into that later. And then I shut down GDIP and exit the app actually. So yeah. Now, side fact. If you want to use your own on exit or anything like that, that will be rather difficult. But you can of course go into this library itself and change it. Now, to continue on with the first function, this is just what I use GDIP in, which is so I have this bitmap here, which I get actually down here at the bottom. From screen, so this is what I need the screen for, and this gets it from the right screen. And here here I have pbitmap, and I delete that first and then overwrite it by this new bitmap that I get from the screen, which is the number of screen. Yeah. So this bitmap I use then to get the pixel color, and if that color is this color, that this is decimal, and it's just because it's returned in a weird format, this would be FF0E0E0. So this is AARGB, so the first F's you can ignore because that's just the alpha and so the transparency, but that doesn't really matter. And then the rest of this is just a color, and it's actually a slightly gray color. Now, it should be white. Normally the numbers in Minecraft are white, but this is not the case for F3 numbers. The reason for that is because this gray backing here. Now, this gray backing is actually in front of the numbers, which is odd, but that's how it works. So yeah, that makes this numbers slightly gray. Now if this is actually this color, I return true, else I return false. Now these are then just checks for a color, for a specific sign. So here I get the scale again, and I use it here to adjust the offset to your GUI scale. So here I just check 3 different pixels, and if these 3 different pixels are all true, it will for sure be this specific color, with this specific sign, which is a minus in this case. So same goes for comma, just that here I actually detect below the line, because the comma always goes below the line and no other number does that. And here I have a few more checks for N, S, E, and W, and these I use to check which direction I'm looking in. This is crucial for the actual reading out of my rotation, because if I look south, the rotation will have a different offset as if I look west. Now I take this direction and actually use it to mod a number by the direction and also by the scale. So I have a function for that. And then I check for have another check for any other number. Basically, this is just much faster as if I had everything for one number, and it's also much easier to do. So this is just a bunch of check if whites. If they are true, this happens, and if not, that happens, and so on. Here I then get all the numbers. I have a few parameters. If minus, you can set minus, so check if there's a minus, or don't check if there's a minus. Check for a comma, or don't check for a comma. And then set x and set y, which are basically the top corner of number, and that I need to actually know where it's gonna be checked from. And now it's gonna get complicated. It's get rotation. So biref yaw, biref pitch means that I can just use the by rotation command and then put in yaw and pitch, and then get that stored in these variables. And here I get the scale again, and here I get this position here. As I said, mod by direction gets that position, and here's the value that I multiply by the scale, because there's the default distance, and the scale, it depends on the scale. Now I get the first number, which could be a minus but can't be a comma, and then I have this 100, which this is the y height, and this is 184 times scale plus 23. The plus 23 is because of the top border of your Minecraft window, or like this Windows internal border. So yeah. Oh, by the way, you have to play Minecraft in maximized mode, but who doesn't? So anyway, here I then multiply this by 1,000. Now, what I do this for essentially is just to check to later on be able to combine all the numbers into a single integer float value actually. So then I just move on to the next number, which is always 12 pixels further, times the scale. 12 pixels are normal, other scale. Then I get the number again. Now it can be comma. Now, yeah, it can be comma, but can't be minus anymore. So that I then multiply by the next lower power of 10. And then, after I've multiplied it, I actually check if it's minus times that power of 10. Now, if it is, that means that it's actually a comma here. So if it's a comma, I add 4 again, now I'm gonna stop talking about the scale, and then I get the number, the next number, and this next number is then can't be a comma then anymore, and this number I multiply by the same value that I would have multiplied this one by. So, and then I just go to the section where I sum this number. Now, if this wasn't actually a minus 200, I move on and check for the yaw. Check for the next digit. So I just have to add number 12, and then I check, and then I multiply the next smaller power of 10. And if it's minus 20, I do the same thing, just with a higher yaw, and so on, basically. Now I do this for... Now, after I've done that, I have the sum yaw section. The sum yaw section first of all checks if yaw 1 is minus 1000. This basically just means that the number is negative. So it's not minus 1000, so the number is not negative. The other way around. So then I check which of the numbers is actually minus 2 times its power. I can't get used to this. And then I just add the numbers and divide them by a specific value that is necessary, because sometimes they are just too big. They're just too big if I didn't get to the 6th digit, where I actually also divided, but the only reason why I divided there is because this is a section where it can be negative, and if it's negative, then I have to divide by minus that number, of course. Now I do the same thing for the pitch as well as I did for the yaw. Then I do the same thing again for x, just that I don't need the mod bidirection thingy here. And this is basically then shown the first 680 lines. Now I have this little function here, which is basically gets the rotation done, and it creates a mouse move command that turns to a specific value. Now, if it turned to these values here, it would actually turn to wouldn't turn at all, and I have to subtract this value from it. Now, yaw to yaw is basically the angle, and then I divide that by 0.615, which is the value to convert the angle into pixels to move. And then I just round that because the mouse move can't actually handle floats. For turn by, I just subtract then this value, the value by yaw divided by 6.15 again from that number, and yeah, then I mouse move, and that's that. And now the fun trigonometry comes into play. I guess I'm gonna start with this. So this walk to blocks just uses walk by blocks and but first gets the x, y, and z, and takes by x and by z to be 2x minus x that I get here, and here you can see the use of a biref. And then it also carries the speed over. Speed just stands for if you want to sneak, walk, or sprint, which also causes higher or lower accuracies. Now, this uses this function here, which is just the one that probably took me the longest. Although it's by far not the longest. Like line-wise, it's only like, what is it? 74 to... yeah, that's like 75 lines or something like that. So pretty short actually. In comparison to like, I think like check if, or like checks for X, Y, and Z carry on for like 300 lines or something like that. But the thing with this is that I actually have to use trigonometry here, and I really don't know that stuff, so yeah. But I hope I'm going to be able to explain it, because some of this was just provided without, and I have no idea how it works. So yeah. Oh, by the way, I have to remove this shit. These comments. So the first thing is sneaking, and that happens if the speed is 0. Then it will get the rotation that I'm facing into, and then it will convert the yaw into a radian by dividing it by this number and negating it. Now this is just, well, it's piped. What this does is to calculate the distance I have to move forward and backward, to calculate the distance I have to move right and left. This then just is a calculator for the time I have to sneak. Now this takes just static value times square root of d1 times 2, which basically means that this is always positive, because it could be negative. And then it starts actually moving. So this sends shift down, sleeps for a bit, and then if d1 is basically this says d1 is positive, then it will press W and sleep for that amount of time I set here, and if it's negative, so else it will press S, and it's the same thing here, but just for left and right. Then it will sleep 30 again and release shift. Otherwise, if the speed is not, specifically not, not 0, it will first of all calculate the angle it has to face into. This is actually something I did myself, which I'm kind of proud of, but hey, it's probably really simple to anyone who understands something of this. So I use A10 here, and I basically, this basically gives me the angle in radians, and then I just have to multiply it by this value again to actually get it in normal degrees. Now, there is a few things that are problematic about this angle. First of all, of course, if I divide by z by x, I will either get a positive or a negative value. But there's 4 states in which by x and by z can be in terms of negative and positive. So I have to later on check if by x is greater than 0, so positive, then I have to subtract 90 from the angle, and otherwise I have to add 90 to the angle. And that I of course also have to have an exception for when x is 0, because I can hardly divide z by x if x is 0, right? So yeah, this just is a manual function that lists the whole thing for 0. Now moving on, I calculate the distance. This is just Pythagoras, and then I turn to the angle I calculated previously, and 1000 just means I face downwards, because I want to have it consistent. Then I check if the speed is 2, so that means sprinting. So then I, in addition to this W stuff, I also have control, and this generally just presses control W down, and oops, I fell. Okay, that's correct. So yeah, and then it multiplies the distance by 127 to get the time I have to run, and I sleep for that time. And I do the same thing for walking, just that here I have a different constant than here, that I have for sprinting, and I don't have the control stuff. So yeah, that's basically that function, and then there's only just one left, which is this function down here, which is get new image. This you have to use every time you want to run everything again, basically. So you need to get a new image from the screen that you can check everything from. So once your player turns, you have to use this again. Once it walks, you have to use this again, basically. You could, of course, also add values to X and Y and stuff, but that would probably just be too inconsistent, so I wouldn't suggest it really. And yeah, that is basically all about this. So now moving on, I would say that I want to start with the actual use section now. Right. So actually I forgot about something last clip. So what I also have to show is my setup for this whole thing. I wrote a little file for that, and it's actually really simple, but I thought it was worth showing too. So I just check if or not this file exists, which is the GDIP archive right here, and then I download that file if it doesn't exist, and put it into this directory, which is just the scripts directory, and then I do the same thing for this file, which is the debug screen reader file. Then following that, I created UI. This GUI I'll show off later on, but essentially what you can input are the three values that I need in my options, which are the screen you play on, your GUI scale, and your monitor size. And no, that's the wrong one. Then I have some options here for what happens when you click on this one, which is a drop-down list where you select your GUI scale. The problem with that is that actually if it's on auto, and only if it's on auto, I need the resolution. So I enable the resolution only if the scale is on auto, and otherwise if I just select something else, I disable it again. And from then I go to the end, so this doesn't get automatically executed too. Just always when I click scale. Here I have what happens when I click this OK button here, and there I just submit the GUI again. That means that I just write everything to the variables, but here I don't have the no hide parameter, so that the whole GUI will be hidden. So then I just delete the options.txt and overwrite it by using the file appends. And then I just exit the app, and yeah, that is basically all there is to this. And now actually I'll move on to showing how this has to be used. Alright, so as mentioned before, this is going to be the setup, and I actually have a little script that sets this up. So if I just double click that, it will first download these two files, and it actually also asked me where I'm playing. So for example, I'm now playing on my second screen, which just has to do with the fact that I'm currently recording this, and on my primary screen I have OBS open, and my GUI scale is normally normal. If it was auto, I would also have to select my screen size, but like this I don't. Sorry. So then I just press OK, and it will also create the options file that I showed earlier already. Now I've already prepared a little program for this. So this is a very, very simple program that basically just let me open the archive library too. There we go. So basically all it does is to get yaw and pitch and store them in the variables yaw and pitch after getting a new image, which you always have to do, and it then puts out this message box right here. Sorry for the little cut there, I missed something. Anyway, so this is just a really simple program, and then I can launch this. Oh, and I already instance of this running. And then if I just press as specified Control B, it will print out my coordinates, which you can't see right now. But this is my, not coordinates, this is my rotation, and you can see the rotation right here. So if you need that value for anything, you can get it. The exact same goes for x, y, z. Just that you have to specify here x, y, z. That was wrong. This way. And yeah, obviously you'd also have to print out something else. And that's just the next function of the get rotation, get x, y, z, as you can see. Now, then these functions are used by turn to and turn by. Turn by basically just allows you, I'm just gonna copy this. Turn by basically just allows you to turn by, for example, 10 degrees and then turn by 20 degrees. So if I do this, I can then just relaunch the net, and I should specify another instance, but I am too lazy right now. So yeah, you can see this doesn't work well if you do it rapidly. Turned by 20 degrees in the one direction roughly, and by 10 degrees in the other. This is not entirely accurate, but just has to do with the fact that I can't turn any less than around 0.615 degrees with this, because if I move one pixel I will be turned by 0.615 degrees. I could modify that if I was to change my sensitivity, but that's something that I don't want to do, because this would be really hard to figure out, and it's not all proportional because for example, if you have your sensitivity at 0, you can still turn. So I really don't know how to figure this out. So this macro does actually sadly only work for sensitivity hyperspeed, but I guess that's the best one anyway. Where some people can't deal with it, but a lot of people are using hyperspeed anyways, so yeah. Anyway, so moving on now, I can also turn to. So if I do this, it will actually just where's Minecraft? I have to first launch this, and then it will actually just turn to that position, as you can see, from anywhere I'm looking. Yeah, like, don't turn more than you need it. So yeah. Then following that's wrong. I have walk by blocks. This is basically just walk to block. So walk to block is basically just inputting into walk by blocks, and walk to block is what I used earlier, and that is actually still in this macro. So let me quickly undo some crap that I did. Well, there it is. So if you just use walk to block, then the coordinate you want to walk to, this is the x coordinate, this is the z coordinate, and then set the speed. Speed 0 is sneaking, speed 1 is actually walking, and speed speed 0 is sneaking, speed 1 is walking, speed 2 is sprinting. And then you just do that, and I always forget to launch this thing. And then you just walk to exactly that block, as you will see now here. And this is basically all the functions of the macro already. Now, it might seem all very simple, but trust me, it wasn't, as I already said earlier. And yeah, overall I think I worked about a week on this. Like, not very consistently, but still a week about. One thing that was especially difficult to figure out is GDIP, because I've not ever used this before. And also the trigonometry. I think I spent like 2 days on each of those. And yeah, it's just also a lot of coding, as I said. This is like 800 lines almost of a macro, so yeah. But that is basically all there is to show. I might look into adding a few things in the future. One of them being reading out the actual block you're looking at up here in the corner. The problem with that is that I'd have to implement all 26 characters, or plus actually underscores or whatever is also used in these names. And I would personally like to avoid that, but yeah, has to be done, I guess. So yeah, that's basically all there is to say. Oh, I might try actually adding a function that a functionality that works for different sensitivities too, but I don't think that would be very easy. So yeah. Anyways, that's it basically. So yeah, bye, I guess.